So we've got normalized floating point numbers here. We've got an 8-bit mantissa and a 4-bit exponent, and they're both using 2's complement. Remember to pay close attention to that in the exam. The reason why I say that is because sometimes they will not use 2's complement, and you just need to make sure you're paying close attention to the bits involved, all right? Now, this is worth 2 marks, but what you need to bear in mind is even if you get the answer wrong, you get working out marks, okay? That may be from working out the mantissa, or it may be from working out the exponent, all right? The easiest one for you to work out first is going to be the exponent. Remember that the far left number is always your negative number. So in this case, what I'm going to have here is 1, 2, 4, minus 8. Okay? So minus 8 plus the 4 plus the 1 is going to give you minus 3. All right? So this exponent now is minus 3. Now, the next thing we need to work out is the mantissa. All right? What I tend to do, again, is this is your negative, this is your like negative 1, yeah? But then this number here, after a decimal, remember, we've got a half, we've got a quarter, eighth, 16th, 32th, whatever, and so on, okay? Now, all I'm going to do is I'm going to add 0.5, written down my answer, 0.5 to 0.25 to, so that's 0.25, and then I've got 0.0625. So that's what those values are. You can do that on your calculator by dividing 1, all right, by 2. Divide 1 by 4, divide 1 by 16th, and it will give you what those decimal values are, all right? That, when you work it out, will give you 0.8125. Now what I've got here, all right, is 2 values that I can work together. This is actually a lot more simpler, and you're allowed a calculator in this exam. All you actually need to do is multiply this number by 2 to the power of your exponent, minus 3. All right? Doesn't matter if you're in your head you can't do this mathematically. What you can do is put that into a calculator, as I have here. All right? Here's one I made earlier. 0.8125 times 2 to the power of minus 3. That gives you your answer, which would have been 0.10152625. Bear in mind, sometimes they ask you to give your answer to so many decimal places, in which case you just need to be aware of that. In the mark scheme, all right, they do give you up to 4 decimal places. So if I had to round that from 0.1016, I would get away with that, because obviously the 6 would make that 5 round up. All right, if you want to watch this back. Can you see here clearly how the mark scheme works from the exam board? You get a mark for working out the mantissa or the exponent. So even if you get the rest of it wrong, just give it a go. All right. Show that the binary has shifted 3 places to the left. So you might have just, in your case, you might have just shifted that number. You might have just drawn arrows, which is what some people do to demonstrate it, and then draw it out again. Do you want to see how that works? So what you might have done, just quickly, you might have done this. 1, 1, 0, 1, 0, 0, 0. You might have moved that to the left and padded it out. This is what I'm saying. All right? To work out what that number is. Now, what I'm going to do next is we're going to do this minus 23.25. All right? The first mark you get is really simple. All you've got to do is show what the number is. Alright, so even if you can't get the answer at the end yet, let's work out what it is. So what's 23.25? Work it out as a positive number first. Alright, so all I would do is work that out, which would be, so this is ignoring the fact that there is 2's complement at this point. Alright, so what I'm going to do is I'm going to work out what 23 is, and that equals 1, 0, 1, 1, 1. Now that's not going to work right now, okay, because of 2's complement. So what I do is I actually pad it out and put the 0 there, because now that is a positive number because this one here is a negative. Alright, so that is, just so you can see it, 1, 2, 4, 8, 16. 16 plus 4 plus 2 plus 1 gives you 23. Alright, so that's worked out. Now, the next thing I need to do is work out 0.25. So all I got to do there is work out, well, I know that 0 is 0.5, and the next number after it is 0.25. So what I've got there is I've got my number as a positive number, alright? What I now need to do, the trick when working this out, is I've just got to flip all of those, okay? So that now becomes 1, 0, 1, 0, 0, 0. So I flip that bit, alright? 1, 0, so I flip them. I'm going to add 1 to it, so flip the bits, plus 1, which gives you 1, 0, 1, 0, 0, 0, 0.11. Now, I'm almost there. To get that to where it needs to be, you've got to look at normalizing it. To normalize this floating point representation here, what I'm going to have to do is get it to its nearest 1.0. Okay, so all I'm going to do there is move this back 1, 2, 3, 4, 5. That's 5 places I've had to move that, right, to the left. So, yes.
If it was 1101, say, where would you put the decimal?
I'll do that in a second. Let me finish this one first, alright? So, I've moved back to 5, right? Now, I now know that there's 5 places for the exponent, which is going to be 0, 1, 0, 1. Okay? And then the rest of the number I can write in. So that is 1, 0, 1, 0, 0, 0, 1, 1. Okay? So that's how you flip the bits, add 1, then normalize it by taking it back, and that gets you your mantissa and your exponent. Alright?